Hello everyone, and welcome to Calculus. Today we're going to be studying differentials. So a differential is something you're actually familiar with, you just didn't know the name of it before. We know that dy dx is another name for f prime of x. Differentials is saying that dy can be considered independently of dx. Instead of thinking of them as a unit, where together they equal the slope, you can think of them as individual pieces. And each piece is called a differential. So if you think about it in terms of a triangle, you know that slope is the rise over the run. The slope is the change in the y over the change in the x. And that is its own independent number. There is a change in y. So if the slope is really steep, delta y and delta y could be really big and delta x could be very small. They definitely could be independent numbers. Together, they form the number that we know as slope. So today we're going to be studying them independently. Find the differential dy, so not dy dx, just the dy, and evaluate dy for the given values of x and dx. So dy dx is the derivative with respect to x, which is 5x to the fourth plus 37. So the differential dy is 5x to the fourth plus 37, clearing the fraction, times dx. That's the differential. Now they want us to find the differential at this point. So dy is equal to 5 times 1 to the fourth plus 37 times dx, which is 0.01. That gives me 5 plus 37, which is 42, times 0.01, which is 0.42. So if, again, going back to our triangle, you can think of it as the dy is 0.42 when the x is just 0.01. Okay, clearly I didn't draw that to scale. So it'd be something super steep. If this was just 0.01, this is 42 times as big, 42. I still didn't draw it to scale, but now you have a better sense of it. All right, let's do the next one. Again, I'm going to start with dy dx, just like I always do. So the derivative of sine of 3x is cosine of 3x, never change the angle, times the derivative of the inside, which is 3, which I'm going to move to the front for safekeeping. Dy dx is equal to 3 cosine of 3x, because I don't ever want somebody to accidentally say cosine of 9x. They just want the differential, dy, so I'm going to clear my fraction, dx, and my final answer is dy is equal to 3 cosine of 3x dx. Now they want to know it at x is equal to pi and dx is equal to negative 0.02. So I plug those two things in. 3 cosine of 3 pi times negative 0.02. So you might have to make a little picture of cosine here because 3 pi isn't one that you're terribly familiar with. Cosine starts at 1, and then at 2 pi, it's back up to 1. So if you go another half time, which would be 1 pi, you'd be back down at the bottom again. And then back up would be, you'd be back up to the top at 4 pi. So at 3 pi, you're back down at the bottom. So this is 3 times negative 1 times negative 0.02, which gives me positive 0.06. So if you're feeling like you get this and you would like to try the next one on your own, dx is equal to negative 0.05. You're more than welcome to try that. All right, so if you're back and you did not get that answer, I can probably tell you where your mistake was. It might have been right here. A lot of times people forget to use product rule. So we're going to go ahead and do that now. The derivative of x is 1. The derivative of y is y prime. Notice I'm using implicit differentiation. And on the product rule, the second times the derivative of the first plus the first times the derivative of the second. I'm going to put all my y primes together on one side, and everything that doesn't have a y prime, I'm going to put on the other side. I factor out my y prime, and I get y prime is equal to y minus 1 over 1 minus x. So dy dx is equal to y minus 1 over 1 minus x. The question is just asking for dy, so I clear the fraction with a dx on both sides. Oops, dx. And my final answer is dy is equal to y minus 1 over 1 minus x dx. They want me now to find dy at x is equal to 2 and dx is equal to 0.05. So I go ahead and I plug that in. Ooh, I don't know why. How do you find y when you only know x? This is going to happen a lot. How do you find y when you only know x? You use the y equation. So this one's not as obvious as it normally is. Usually our equation is y equals, but you can still do it. So I'm going to put a 2 right in there because it says x is equal to 2 and x is equal to 2. I subtract y from both sides and I get y is equal to 2. So when x is equal to 2, y is equal to 2. Now I can continue. 2 minus 1 over 1 minus 2 times dx gives me, this is just negative 1, negative 0.05. There you go. So how do differentials work in real life? Well, we can use them to estimate the change in the value of a function. The approximate change in the value of f of x when x changes from a to a plus delta x is df is equal to f prime of a dx. This is pretty much the same thing as dy is equal to the derivative f prime of a dx. They've just moved the dx onto that side. So how does that work in a real problem? They want to calculate the change in area. So the area of a circle is pi r squared. If I take the derivative with respect to the radius, I will get 2 pi r. And by the way, you might remember I did this a couple videos ago. I just think it's a hugely fun fact that the area of a circle is pi r squared. And the change in area, dA, if you want to change that area with respect to the radius, it would be 2 pi r. And do you recognize that formula? That's a circumference. 2 pi r is a circumference. So adding a circumference, adding a layer, is what would change the area, which is just a cool fun fact. Okay, but we want just dA. So I can change the area by doing a circumference, or 2 pi r, times however big that r is, that change in r. Am I adding just a thin layer, or am I adding a big r? This will tell me what my change in area will be. So we're going to go from 10, so dA is 2 pi 10, to 10.1. So the change in area, the dr, is 0.1. Well, this is actually just 10 times 1/10, so they cancel each other out, and I get 2 pi. So if I change a radius from 10 to 10.1, the change in area is going to be 2 pi. That's how much area I'm going to add. Let's see how close that was to the true change. So if you didn't know any calculus, how would you do this problem? You would literally do it with the area formula. You would say the original area is equal to, when the radius is equal to 10, is pi 10 squared. area is equal to 100 pi. And then the new area, when r is equal to 10.1, would be area is equal to pi times 10.1 squared. You'd get out your calculator. 10.1 squared is 102.01. Area is equal to 102.01 pi. And then you would actually figure out the difference. So the difference is 102.01 pi minus 100 pi, which is 2.01 pi. Ooh, what did we get? 2 pi. And that's why it's just called an estimated change. You're not finding the actual change, but differentials is a great way to estimate how much the area is going to change. And you have to admit it was a ton faster. We did the derivative and just plugged everything in. The way anybody who doesn't know calculus would have to do it is to do the original and then the new and then calculate the difference. All right, both questions do ask for a percentage change. So for a percentage change, that would mean you would take the new amount out of the original amount. So pi r squared would be 100 pi. And then to change it to a percentage, this is going to come out to be some fraction. You would multiply by 100. So in this case, it comes out really easy. We don't even need our calculators. The pi's cancel, the hundreds cancel, and we get 2% change. So the change is 2 pi. It was originally 100 pi. As a percent, that's 2%. In this case, again, this is going to be equally easy. But to find the percentage change, how much it changed, divided by how much it used to be, and then times 100 will always give you the percentage change. So it's actually a 2.1% change. If it helps you not to think about it in area, you could think about it in terms of salary. If you were making $15 an hour and you got a 50-cent raise and you want to know what was that as a percent, you would say, well, you got 50 cents out of $15, but does it make sense that that's going to give you a decimal? So it's going to give you 0.03 repeating. So to actually figure out what that is as a percentage, you'd have to multiply by 100, and you would get 3.3 repeating percent. So 50 cents is a 3.3% raise. It's always what the change is divided by the original amount. And then the times 100 is just to change it from being a decimal. But if you need that in a little chart, the book had a chart, so I went ahead and I copied it down. True change versus estimated change using differentials. But we're just going to be using differentials. A ball loses 0.2 inches of radius during its normal use. If the initial radius was 3, estimate by differentials the change in volume. So volume of a sphere is 4/3 pi r cubed. The derivative with respect to the radius, bring down the 3, is just going to be 4 pi r squared. So I can calculate just the change in volume by doing 4 pi r squared multiplying both sides by dr. Like this. This will give me how much the volume changes if you just tell me how much you're changing the radius based on how much the radius actually was originally. Because it makes a difference if you have a small radius and you change it this much, or if you have a huge radius and you change it that much, it's going to affect the volume. Even though these two changes in radius might be the same, depends on how big you start with. So what are we doing? We're trying to find the change in volume of a ball that started with a radius of 3, and we're changing it by 0.2 inches. It says it's losing 0.2 inches, so this is a negative dr. And this will tell you its change in volume. So 0.2 times 9 times 36 is going to be 72 with decimal 7.2 pi. And it is going to be negative because it's decreasing in volume since it's decreasing in radius. Is that going to be the exact perfect answer? No, but it'll pretty much tell you it's an estimate, but it's close. All right, this next one is my favorite. Suppose the Earth is a perfect sphere. Obviously, it's not a perfect sphere. There's mountains and valleys and oceans, and doesn't make it perfectly round. But scientists have tried to determine the radius. So they think that the radius of the Earth is 3,959 miles, give or take a tenth of a mile. That's amazing. It's amazing that they can come up with such a good estimate, even if they're off by a tenth of a mile. It doesn't really matter, right? It's about 3,959 miles in radius. So the question I have is, how much does that, give or take the 0.1, how much does that affect the surface area calculation? So surface area of the Earth, of any sphere, is 4 pi r squared. So dA dr is equal to 8 pi r. And I'm going to clear my fraction. The change in area is 8 pi r dr. So now I'm actually going to figure out the change in area based on the radius of the Earth, 3,959, times the dr. So they're saying, you know what, we might be wrong by 1/10. Okay, cannot do this in my head. I'm going to have to get out my calculator. It comes out to 3,167.2 pi, which is approximately, you got to multiply that pi out. That's not really very helpful when it comes to actual measurements. So about 9,950 square miles. Any idea how big 9,950 square miles is? It is literally the size of Maryland. So if they're wrong by a tenth of a mile, they've lost Maryland. Poor Maryland. Anyway, I just find that really fascinating that you might think, oh, they're off by a tenth of a mile. That's really not that much. But when you start taking that answer and putting it into other things, look how big that error is. So on that note, for the last one, it says, how accurately should you measure the side of a square to be sure that calculating the area is within 2% of its true value? So this one's usually the hardest. Most people really like differentials, but this one does seem to cause people a little trouble. The key is getting this little first step. You want the change in area to be less than 2%, which as a decimal looks like that, of means times, and then we want the true value. What is the true value of the area of a square? It is x squared. Okay, so this is the key statement. You want the change in area to be less than 2% of the actual area. And what is the actual area? 2x, or x squared. And what is dA going to be? You can do that off to the side. If a is equal to x squared, then dA is 2x, but this is really dA dx, so I have to move the dx to the other side. So this is going to be 2x dx is less than 0.02x squared. If you let your mind understand this equation, then this problem won't be so hard. Don't just memorize it. Understand it. You want the change in area to be less than 2% of, always means multiply, its true area. All right, to finish solving this, I'm going to cross one of the x's off of both sides, and I'm going to divide both sides by 2. That gives me dx is less than 0.01x. If you write this on a test or a quiz, I'm not going to give you full credit for it. Because if somebody walked up to you and said, how accurately should I measure the size of a square? I got to make sure that the area comes out within 2%. And you said dx is less than 0.01x. That's not an answer. I need you to understand in words what that answer means. So the dx represents the change in the length of the side. And now we see the less than must be less than what? What does this represent? 1%. So we're going to change it back to a percentage. It's written in decimal form. It's being multiplied, so I write the word of the true length of the side. Always answer a question with a real answer. So the change in the length of the side must be less than 1%, or you could say the error in the measure of the length of the side. Okay, something that indicates you know that how you measure it needs to be within 1% of the true length. All right, that's it. Have a great day.